Welcome to Gate Learnings. So today topic is Karnaugh Map, is also called as popularly K Map. So it is one of the important topic for a gate. So let's get into it. So K Map, it is a like graphical representation. So the purpose of this K Map is to solve the Boolean expressions so that when we implement this expression using logical gates, it can be reduced. Like if the expression is the huge in Boolean expression, so directly implementing it will be cost. So to reduce this cost using this K-map, reducing this Boolean expression into a simpler version, and so that when we implementing this expression into logical gates, the number of gates used will be less, so the cost will be effective. So let's get to the topic. It is a graphical representation to solve Boolean expression. So if the Boolean expression provided n variables means, so to represent in the graphical representation we use cells. So like for two power n cells, two power n variables means we need to have 2 power n cells. So for one variable, two cells. For two variables, you have four cells. Three variables, you have eight cells. So how these cells are represented? So for two cells, uh, need to represent like this, these two cells for one variable, 0 and 1. Similarly for four cells, these are the four cells. So two variables, right? X and Y. Here one variable means X. So 0 and 1, 0 and 1. So you need to represent 0, 0, 0, 1, 1, 0, 1, 1. Similarly for 8 cells. So three variables, right? So X, Y, Z, 0, 0, 0, 1, 1, 0, 1, 1, 0, and 1. So you need to present like this. So let's get into the solution solving by examples to explore much more in it. So first example, uh, So they provided some minterms. So we need to solve by using this KMF method. So if you look into it, so this is a six, totally four minterms they provided. So they are three variable contents, right? So three variables means, as said, eight cells. So form eight cells. So eight cells. Consider as A and B, C, 0 and 1, 0, 0, 0, 1, 1, 1, 1, 0. So first, 1. 1 equivalent is, we can represent as 0, 0, 1. A dash, B dash, C. So here 0, 0, 1 and 4, 4, 5, 6. So we need to place each minterm in the respective position. This is uh, this is the 0th position, first position, second position, 0, 1, 3, 4, 5, 6, 7. So their equivalent binary numbers should be placed. So here the 1 is first position and 4, and next 5, and next 6. So after placing these minterms in the K map, we need to form like a grouping. So maximum number of ones by grouping, right? So here 2 and 2, 1 and 1. This is the first grouping, and we can group like this for this 1 and 1. So by grouping the number of ones, so we can reduce the Boolean expression in a simpler way rather than by using this postulate theorems. So for this grouping, the expression will be, as the A is changing from 0 to 1 and B and C is constant, right? B and C constant terms only, C, B and C. And for this grouping, as the A is constant, right? A, and B is changing from 0 to 1 and C is same. So write the constant terms, right? So we need to write C, A dash C. So the expression is B dash C plus A dash C. This is um, the reduced expression. If we didn't reduce this expression, the original expression will be according to this question. So 1 means A dash B dash C plus 4 means A B dash C dash plus 5 means A B dash C, 6 A B C dash. So this expression is reduced into two terms. So the number of logical gates will be reduced.